Hi everyone, this is Yash, and what I wanted to do was build an AI agent which works on local. And with the recent models like DeepSeek R1, they have really improved the accuracy of the models. So even the smaller models work really well, which we can run on local. But what I realized is when I started using the DeepSeek R1 1.5 billion model, distilled model on Qwen, it didn't have tool calling, but I decided like let me just use the ReAct prompt itself and give the raw prompts to get the tool calls, and then I can like programmatically make the tool calls myself. I realized like the ReAct prompt was not giving that good of results. So I decided like let me fine tune this model on ReAct prompts so that I can get a model which I can use to build my AI agents on local. That is exactly what we are going to do. But let me at least first show you what the outputs look like with the raw vanilla model. So I'll just import Olama here, and we'll use this to make inferences from local model. Let me also quickly paste the ReAct prompt that we want to test it on. So this is the ReAct prompt. Like on our channel, we have built AI agents from scratch that was using GPT-4 4.0 model. But we use this exact same ReAct prompt that we used. We basically give access to like 4 tools. We describe like what those 4 tools do. So in this case, it was search product, add to cart, summarize cart, and then buy product. And we tell it like how we want output in a specific format. So if it wants to call a tool, it will use like something like action, search product, and the product name. And if it doesn't have any actions to take, it will give out the answer saying the final response that it wants to give the user. And this runs in a loop, like we parse out the output. We keep calling the prompt till we reach the final answer. So we'll put in this ReAct prompt as system message, and we'll add a user message which is the actual query. Then in this case, let's buy some red roses. It was 14th Feb yesterday. We are late, but yeah, we are men, so we are usually late in these kind of things. And we'll pass this message through, let's say, the DeepSeek R1 1.5B model. This is the distilled Qwen model. So if you haven't downloaded the model, you would have to uncomment this line and run this as well. But since I have already downloaded the model on my local, this would work. So I'm sending in this messages that we created to this model. And the hope is that it will output saying, I want to perform an action of search product on red roses, because it should search the product first. Yeah, so we got the output after a while. I think it thought a lot. So this is where the thinking ends. And here we get the output saying, thought I want to buy red roses first. I need to search available red roses plants online. This is going good. It says action, search product, and then it says like end message action will be performed. And it says observation as well, search product, return product matching query. And then it gives like final answer saying search results has been displayed. If you want to add product to cart, please specify the product. I mean, it's picking up from here somewhere, like these kind of instructions that we gave, but it's still not exactly parsable output, and it's messing up, even though this part is correct. But if you know the loop, how we write it, we will have to parse this output and actually write some logic around it. That logic would fail in this case. And this is also like a little bit nonsensical output, like it's saying like results have been displayed, but we haven't even gotten the results. Like it should have ideally stopped here, and we would have actually performed that action and given it the results, and then it could have actually displayed. But yeah, it decides to just go ahead and hallucinate and whatnot. So I've decided to fine tune this model further with very specific prompts, ReAct prompts with different tools and all. And I've also pushed the fine tune model on Olama. So before getting into how to fine tune and all, I want to show you the response of the exact same message if we pass it through the fine tune model. So this is the fine tune model's ID. I've pushed it on Hugging Face, but we can use it through Olama because it's GGUF. So when we pass this exact same set of message through this model, let's see what we get. Okay, even this took slightly less time, but and then it says like, thought I should search for product related to red roses to find suitable options for purchase. And it says action, search product red rose, which is kind of correct what we want. So this is what we can parse and we can use it. And even here in this case, like don't be completely sold on this. It does make mistakes as well. It's not like a very perfect model, but something works, something that works, and maybe you can get it to work with maybe some more prompt engineering, or even the fine tuning pipeline has a lot of gaps which we can improve. I'll discuss everything. Great. So let's get into how exactly to fine tune. I've pushed all the code on my GitHub. I'll paste the link as well down in the description. But at a broad level, we'll be using Unsloth for training. So let me open this notebook, and this notebook, the code was all ran on Google Colab because we need some GPUs. I wanted to keep it like free of cost so that anyone can do it, and Google Colab was the only way where we get GPUs. Even if it's like restricted manner or whatever limited access we get, it's still amazing. So all the more power and all the more respect to Google Colab for doing all that. Yeah, so I was saying like we'll use Unsloth for this, and Unsloth is like a library that has come up recently. I got to know about it recently, and it is super amazing. It's the fastest library to fine tune any LLM right now, I guess. Yeah, like this is a package that we are going to use, and you can also go through the documentation if you want. This is what I was referring to as well. There are several other sources that I was referring to. They have also given like a Google Colab notebook directly if you want to refer. So they have shown like how exactly to fine tune. But yeah, like I've used that as a reference, and I have adapted it to my use case about ReAct, and there are a lot of nuances here which we can discuss. So we'll first install Unsloth. This will all happen on Google Colab. You can try it on your local, but for me at least it didn't work because Unsloth doesn't support if NVIDIA GPUs are not there right now. So for me it was failing even when I tried to load the base model. But yeah, once we install Unsloth, we can start loading in the base model here, and you can see like we'll be working with the DeepSeek R1 Distill 1.5B model, the Qwen model. In the docs they say like basically you can mention any of the Hugging Face model here. It would work. If it doesn't, it'll just give error. Most of the models I think would work. Max sequence length, they said like it can be anything, but for testing purpose it can be 2048. This is what I have done. I've kept all these three params value as is, like default, whatever they have said in the reference doc. Whatever output you see here is from Google Colab. So like basically whatever GPU values you see, it's all from Google Colab itself, and it's from the free tier Google Colab. So anyone can have that access, I guess. Now once we have this base model loaded, what we want to do, main thing is we want to create our data set that we want to use to fine tune our base model. So what I first did was I checked the prompt format for the existing model. So I used this tokenizer that we loaded. So this is the DeepSeek R1's Distill models tokenizer, and I passed in like set of messages and I applied the chat template. So just user assistant messages just to see what kind of formatting they are doing on the chat for this particular model. So this is what comes out. Like first a beginning of sentence token is added, and then we add a user token, and then the actual user message that was told first. So this is the first question, it's coming from here, and then an assistant token and the response to the first question, and then an end of sentence token is added, and then again user, this is the second question, assistant, response to second, and end of sentence. So this is the loop that goes on. So this is the pattern that we found out, and this is the pattern that and the format that we'll use for our dataset as well to train the model, because the model understands this format and we should also respect that. So it's time to load our dataset and put it in that format. So what we'll do here is we'll read it from this React dataset.jsonl file. This is the file that I had uploaded on Google Colab, but let me open this file and show it to you how it looks. It's present in the repo, but yeah, the viewing experience is not good. Let me open it in Jupyter itself. Yeah, so the dataset contains 60 odd messages. So if you can see here, like there are 60 messages here. 60 data points that we want to train on, and each line is a JSON containing a key called messages. So if you see, there is a messages key, and key messages is a list of the value is a list. So in this list we have like utterances. So first is like list of this is list of objects. So role is system, and the content is actually the React prompt that we have, the description of tools and all. The next message is from user, it's actually a query, And the third message is the assistant message of what the actual response should be, the expected response. So in this case, it thinks that hey, I should search for suitable pants which is suitable for purchase, and then it calls action search product pants. So this is what the expected data looks like, the data set that we want to train or fine tune the base model. And if you see here, like further on in next set of examples, I've added like different tools as well, not just the search product and those particular 4 tools. I have like a mix of tools in each of these ReAct prompts so that it generalizes to different tools as well. So this uses like search recipe. For searching a recipe, there is a tool. For actually making a dish, there's a tool. And then a user can say like, I'm hungry, and the thought is like, user says but hasn't specified what would they like to eat and all. So this is another example. Like I saw like in one iteration, when I actually fine-tuned and I saw the results. When we say something like this, the LLM should realize that I need to call a tool with an input, but user has not specified what input will go to that tool. So it should in turn ask the user for more inputs. So these are some examples that I added later on after realizing that, hey, I should add these kind of examples as well. And then once user answers those, it will call the tool with those inputs that are there. So this can be like different variations of data points, data set, which you can add in your data set. And then also like longer conversations. So I think I saw one of these. Yeah, so one of these examples, it has like 21 messages. So you can imagine like you can give like longer conversations as well for it to know like hey, things can get long. So in this case, like I've actually added the observation of the tool. So maybe the user asked for searching some shirts, and then it's searched for like blue shirt, and here we add in the user message, but this is the observation of actually calling that tool. So if you see from the previous video, this is similar to, like, you'll know what I'm talking about here. It returns the list of products. This is the list of objects which we add in like as observation, and here the assistant will take this observation and display it properly for user to see. If you take this and print this, so it has like proper structure and all. One thing here I noticed, like I haven't added the thought and answer field. This should have been like thought, we have gotten the observation, so I'll just return it to user, and answer colon, and then this should have followed. So maybe the data set is also not that good quality. So even this can be like one of the gaps that can be improved to further improve the model performance if it's not performing that well. Maybe I've not paid much attention to the data set. I should have. I've created this data set fairly manually, but I've also used inputs and outputs from 4O model. So from the previous projects that we built for using 4O, I just gave the input and took the output, got both of those things, and made it a data point. And then I've also used ChatGPT to generate some more examples with some manual tweaking after I got the response from ChatGPT. That's how I have generated this data set. So you can kind of say like it's a further distillation. We have taken outputs from 4O, which we are passing down to our model now, which is already a distilled model, and we are distilling it even further. But yeah, I might have missed these few cases where I have not done a great job. This is something that can be improved. So now that we know what this React dataset.jsonl file looks like, what we do is we read in like a list of objects here, and we'll create a Hugging Face dataset out of it. So this Hugging Face dataset we'll create from this list of objects, and we'll apply this map function. This map function will take each example, read the messages from it, and for each of these messages we'll loop through these messages and keep adding to this formatted conversation that we have started. It starts with beginning of sentence tag that we have seen here. So beginning of sentence, and then the system message is just appended as it is to the formatted conversation. But if it's a user message, we add this user token. Assistant message, we do something special here. we add the assistant token, but we also add this thinking line here. Ideally, I should have put more efforts in this, but I completely forgot about this, and then I didn't want to go back and redo all the work. So I just added this hard-coded thinking message for now. Since user has anyways asked to put thoughts in the thought section, I'll put the thoughts there. So in a React prompt, we already have like a thought section where we put the thoughts, where the LLM puts the thoughts. So I just put this in the thinking part, but definitely this should not be hard coded. You can add it in the data set, and it can be different for different data points. And we add the message, actual assistant message here, and we add this end of sentence because we saw after every assistant message we were using, so this was the assistant message, we put this end of sentence as well. So this is what we do, and we add this formatted conversation to the key text. So if we see the data set, it contains two keys. Messages is the actual messages that are coming from our JSON-L file, and text is the formatted one. So just to print like one example from text and show. So one example, it starts with beginning of sentence, and this is the system message, basically the React prompt where we give the tools. So in this case, we have like three tools: create playlist, add to playlist, and get playlist. And then user queries something like, hey, can you create a playlist with these songs? Assistant says, definitely this is the think hard-coded message, and then assistant thinks about creating a playlist and putting these songs in it. So it calls this action of create playlist with these songs, and there is end of sentence, and then observation. This is like the actual tool call observation. So here it's like a natural language output, but it can just be like true or something, since it's a function call for creation of playlist. And assistant again, in the thought section. Oh, here the thought is also missing. So yeah, maybe the dataset is not that clean now that I'm realizing, like while discussing all this. But it directly gives the answer saying, hey, these songs are a playlist is created with these songs, and then there is end of sentence. So this is how one of the data points looks like. You can see other data points if you want to, but now that we have our data set formatted, we can go ahead and start training the model. So this is how we set the model for training. We pass in this model and we create this PEFT model using unsloth packages itself. This is similar to how we do in Hugging Face as well. We can discuss like each of these params. Even I have not gone like dwelled upon it too much. But two main parameters that I saw very useful was this R and LoRa alpha. These two params kind of determine like the trainable parameters, the number of trainable parameters. So higher the number, more number of parameters that will be trainable. So what I was doing is, when I trained this model earlier, I was keeping this number low as it was in the reference doc. So I didn't change these numbers initially. I just used whatever was there in reference, and it was taking very small amount of trainable parameters, and model was not performing that well, the fine-tuned model. And I came in and I just increased these numbers so that I get more parameters to train with the exact same data set, and I was getting good results. This is also like coming from how we are progressing with GenAI right now. Like just throw more parameters, just throw more data, and then we get a better model. So something similar here happening. You can also tweak these two parameters to get more trainable parameters in your LoRa model. Other parameter you can read, but personally I didn't touch any of those. I'm just using like whatever was given in the reference doc. And then we actually create a trainer by giving this LoRa configured model here, and we tell like in dataset. So this is where we provide the dataset as well, and we tell it like which key to use to actually train the model. So we have saved it in text, and that is what we have given here. And even here, like not many parameters are useful for us, but some of the parameters that were useful for me was max steps and learning rate. So initially learning rate was too low. It was training, but it was going very slow. So when we actually get this trainer and we call trainer.train, it starts showing us this number of steps and training loss and all. So this learning rate was very low. It was 10 to the power -4, -5, I don't remember. I think it was -4. But I increased it and it started going down at a faster rate. So it was fine. It was still going down. It was not going up. So I think it made sense to lower this, to increase this. And also max steps I had tweaked to some extent. So even now with 50 steps, if we see, like, it's still going down. So I think I could have increased it even more than 50, maybe made it 100 and seen, like, maybe we would have gotten like better model. These are the only parameters that I usually tweak. Rest all the parameters I keep it as it is. I don't even know honestly like what they mean to a great extent. So yeah, like once we kick off this training, it trains, and then yeah, we can start doing inferencing from the trained model. So we convert this, we get this model ready. This is the fine-tuned model now, and we get this ready for inferencing. And this is how we do it in Unsloth. And we pass in one example message here. So this is similar, like we have given like a ReAct prompt, and then we have given like a user query. I'll show you the exact prompt how it is done. And we are asking it to generate. So this is the generation that it did. This is the formatted prompt you run, and then we have given it two tools here in this example: find restaurant and book table. And let's go down. So this is the where the system message ends. So user says I am hungry. Assistant says so this is still input. Everything till here is still an input. Yeah, till here. I'll show you the example as well, so that you know I'm not scamming you. Yeah, so this is the last user message. Like we get the observation of the search results. So maybe in this case, user is trying to find something to eat, and assistant asked like, what type of food are you in the mood for? And user said, I'm in the mood for Italian food. Assistant said, action, find restaurant and Italian. And then user returned the observation for those for that actual action that was performed. And now here, this is the actual generated result from our fine-tuned model. So once assistant saw the observation, it says like the user has provided the search results. I will now format them for easier viewing, and it starts printing this answer. So this is what we would parse and we would present to the users. So here are some Italian restaurants to choose from. 1 to 3, it lists it down properly, whatever it had received from the user. And it's also asking like a follow-up question: would you like to book a table at one of these? Which is great, which is absolutely great. This is what we wanted. So yeah, I mean, we can start using our fine-tuned model in Unsloth itself. But let's also see like how do we save these models and push it to Ollama as well. So since this model is the fine-tuned model, we'll save it. We can use the save pre-trained function from Unsloth, and we can name this model something. Let's save the model and tokenizer. And then since this was Google Colab, I just use this command to zip all the files present in this ReAct model, since the model and the tokenizer were put in that folder. Now when we call this save pre-trained, it saves only the LoRa layer of that model, only the parameters that were trained or fine-tuned. So not the complete model will be saved, only the LoRa layer, which is fairly like small, like around 20 MBs or so. So only that is enough, like for saving purposes. We'll see like in the next notebook, like how do we read that model, how do we load it, and how do we push it to Ollama as well. But once you zip it, you can download it from Google Colab, just to have like a checkpoint thing, because Google Colab keeps kicking me out of the GPU instance because of some resource constraints that they have put. So it's good to have like a saved model, checkpoint it, so that you can start from there rather than starting from scratch every other time. Great. So now that we have like trained model saved, let's also go to this notebook. Actually, I haven't pushed the LoRa weights. I'm thinking I'll push the LoRa weights as well in this repo, so that you can pick it up from here as well if you want. So in this next notebook, we'll see like how do we read that trained model, and how can we get inferences from that trained model, and also how do we push it to Olama and get inferences from Olama as well. So again, we just install Unsloth, and what I did was I uploaded this ReAct model zip file that we had again in Google Colab, and this time I'm doing unzip now. And now once this is done, I can use Unsloth to load the model, and this time I'm not loading DeepSeek R1 1.5B Distill or anything. I'm loading my folder that I uploaded, the LoRa weights that I uploaded. So what this will do is this will also download the base model that it uses, since the model has the information which base to download. So it will load the complete model, not just the LoRa weights, but the complete 1.5B distill model as well, and get the model ready. Yeah, this is like at this point we can again use it for inference and get our inferences. So this is another example, like maybe here I gave some other set of tools. Let me check here. So I gave like 2 tools, check whether, set reminder, and the user was like, can you help me set a reminder? And the assistant was like, user is asking to set but haven't specified when and what task is. I need to ask them for details. So it asks like, sure, what's the time and task you would like to set reminder for, since this set reminder tool in our case takes time and task as input. So it's asking that, which is absolutely amazing, and this is what we want. So now once we have this model working, this is where we had left off in the last notebook as well. We can sort of push this to Hugging Face Hub. Unsloth has methods to push it to get the GGUF model and push it to Olama as well, but I prefer using this hub method more than directly creating GGUF, because for me at least it had some issues. The Unsloth was unstable in GGUF case, but maybe they would have solved it by the time this video was recorded, so you can try directly from Unsloth as well. But this is also a good method to have. Like what we can do is we can push the merged model. So what does merged model mean is the complete model, not just the LoRa weights, but this time the complete model will be pushed to hub, and you can specify your username, what model name would you like to give on Hugging Face, and you can give your HF token here, and this will push the model basically to Hugging Face. You can also save your complete model as well if you want. I don't know why would you do this, but you can also save it locally. In the last case, we only were saving the ReAct layer, the LoRa layer, which was only 20 MBs, but you can save the complete model, the 1.5B model, and the LoRa weights completely. So once you have pushed your model on Hugging Face, you can literally convert it to GGUF format by using this Llama CPP project. But there is also this space that exists on Hugging Face, which takes in like which repo you want. Of course, you have to log in. I let it load first. So of course you have to sign in here, and you can literally like search for exact model that you want. So for example, if I go check my username, I have 2 models, but it was only one model till we pushed it. So this was the model we pushed. We can select it, and we can literally select like what kind of quantization we want. And once this is done, we can submit, and it will automatically create a GGUF for you with that quantization and push it. And this is where I got this GGUF from. After clicking submit, it will automatically be pushed because you have signed in, and you will get something like this. Now this GGUF you can directly use through Olama. If you see, yeah, so we were here. So you can follow this link to convert it to GGUF once you have pushed it to Hugging Face. And that's it. Like once you have the GGUF, you can use Olama to use that model. Now since we were in Google Colab, I need to install Olama and start the Olama server on Google Colab. And we can install Olama, and this is how we can start getting inferences as well from Olama. So this is the example where I pulled like the vanilla 1.5B DeepSeek R1 model and got a response from this. This is another example now. I don't know why I used so many different examples, but yeah, just to show you, just to show off maybe. So this is from the vanilla model, and then We can also use this link now. So this is a Hugging Face link, but we have pushed like a GGUF model, so we can use this model as well. So this is again like a comparison of the vanilla model giving some long, very confusing response. So it's giving like find movie and empty and whatnot. But here we can see like it's asking like, sure, what genre are you in the mood for? Like, because this example, maybe it takes, the tool takes like what genre and find movie and so on. So yeah, this is how you can, push your fine-tuned model and start building things using this. So this code we have seen, like it works on local now because it's a small model, and it runs perfectly well on my 8 GB RAM laptop. My laptop has only 8 GB RAM. It still worked pretty fine. So we can start building AI agents, I guess, using this by parsing the responses. So I just want to discuss few things that I tried while doing all this experiment, so that you can learn from my mistakes. So one thing is, as I told earlier, like I didn't have any examples in this data set where uh, where LLMs ask user for input. So it was not really asking; it was just assuming and going forward. It still does sometime. So maybe we can add more of those examples, but I hadn't added it in the first place at all. So more varied data set, more cases can be portrayed in the data set. Like even now in this data set, I don't have an example where a tool call failed. So let's say an observation returned like an error, so it might retry the tool, or tweak the inputs of the tool and try with that inputs or something like that. So those examples are still not there in this data set. Maybe we can add those as well, so that our model is better at handling errors from coming from the tools very intelligently. Another thing was I fine-tuned 1.5B and it didn't work. So I thought I should use a bigger model. I tried 8B, the distilled 8B llama model, again DeepSeek R1, but that was requiring like more GPUs than Google Colab can give. So I tried switching to this other model. Yeah, this was the model. So Llama 8B, but this is a 4-bit quantized model. So this is something that I tried, and this worked. But then when I pushed it on Olama and I took it on my local, that time it was a big model, and it was not, the fine-tuned model was not working on my local then. So that was the issue. So I did a bunch of things over there as well, and then I went back to 1.5B because that is the only model I could afford to run on local. That's when I increased the R and LoRa alpha values to actually get it to work, because that's another way how you can increase parameters. One way is to choose a bigger model as well to fine tune, but the other way is also to tweak the LoRa parameters to have more params to train. Another thing was in this data set I had like new line. So even if you see my old videos about creating AI agents from scratch using 4.0, we had a new line here. So it gives a thought on first line and action on second line, or answer on second line. And I saw like after the model was trained, it was struggling to generate this new line. Like it was giving the thought and that's it. This is where it was ending. It was not giving the action and everything on new line or anything. So I thought maybe let me put it in one line itself. So this is how I tweaked the data set as well. I just removed the new line, but this is still parsable. Worst case, we can just replace action colon with new line action colon, so the response becomes exactly the same. So even the same parsing would work. But this is something I did, removing new line so that it becomes easy on model. Maybe, I don't know. I also tried replacing this thought with thinking token. So I had to revamp the complete system prompt. And so system prompt right now says like give thought, give action or answer. So I changed this to give thinking tokens. So think and the actual thought, and think end, rather than give a thought as another section. That didn't work very well, but maybe I didn't spend a lot of time there. If I would have experimented, I would have gotten better results, I guess. But I ended up adding like a hard-coded message in the think tags, which gets the work done, but that should definitely, we can revisit that part. One thing was about quantization. So even if we go to that link, so to GGUF, your Hugging Face repos, if you see quantization, there are a lot of options to quantize. I tried reducing the quantization to a great extent when I saw like the 4-bit Llama 8B model was not getting loaded, and the results got like a lot worse. It was just random responses at after 1 point of quantization. So 8 is the best one, of course, like, but we can still push the boundaries a bit, go a little lower, maybe 4 or something. So quantization is another place where you can experiment. It's all about like speed versus accuracy when it comes to quantization. I feel it will increase the speed of the inference, but how accurate will be the response is the question. One last, okay, this is the last one, I promise. Since you already have this data and it's already in the format of OpenAI fine tuning, you can also use this exact same data and try fine tuning like 4.0 mini OpenAI model. When I was building the project from scratch, I had tried 4.0 mini and it was giving bad responses, same as 1.5B that we see on local. So we may use the exact same data, fine tune 4.0 mini as well if we want, and maybe enjoy that model as well. So that is another thing that we can do here. Yeah, for now that's all. We have like a running model here, which to which we can give our tools now, and we can parse these actions. You can maybe refer to the other video to see how we build this pipeline end to end. It's same now, like how we build it with 4.0. The same exact thing we can replicate and start building AI agents on local. Hope you like this. Consider subscribing. I'll see you in some other video. Thanks. Bye.